A 68-year-old man with a history of metastatic pancreatic carcinoma presented with a gastric outlet obstruction and was referred for enteral stenting. Gastroscopy revealed a marked stenosis in the first portion of the duodenum from extrinsic compression. The first step in stenting such a stenosis is to pass a wire safely through this area. One method is to impact an inflated balloon catheter up against the stenosis and inject contrast to identify the channel. The inflated balloon is marked by the first arrow here, and the duodenal contrast below the obstruction by the second arrow. With the insufflated balloon pressed up against the proximal portion of the stenosis, contrast can be injected, demonstrating intraluminal positioning. At this point, the guide wire can safely pass into the distal duodenum. The balloon catheter can then be deflated and passed safely over the wire into the distal duodenum. This is demonstrated here. At this point, the balloon can then be insufflated and then gently pulled back against the downstream margin of the stenosis. With the endoscope positioned near the upstream margin of the stenosis, the area between the balloon and the endoscope gives a rough estimate of the length of the stenosis. This maneuver clearly identifies the position and the length of the duodenal stenosis, indicating the length of stent to be used and localizing the midpoint of the stenosis. The balloon catheter is then removed, leaving the wire in place over which the stent is passed. Once the stent catheter is positioned in the midpoint of the stenosis, the stent can then be slowly deployed. Caution needs to be used advancing a stent across an angulated region of the stenosis, as this tends to push the endoscope away from the stenosis itself. This requires gentle advancement of the entire endoscope and stent as a unit in order to achieve ideal close positioning for deployment. This is demonstrated here. Once the stent positioning is felt to be ideal, slow deployment of the distal end of the stent can begin. For some stents, deployment results in stent shortening, so positioning adjustments need to be made during slow and careful deployment. The process of the deployment is observed both endoscopically and fluoroscopically to ensure proper positioning. If a major position change is necessary, most metal stents can be recaptured by retraction of the stent into the retaining catheter as long as only partial deployment has occurred. Here we see positioning the endoscope in order to achieve a more straight position prior to deployment of the proximal end of the stent. And here we see the ideal positioning of the proximal portion of the stent in the antrum of the stomach fully deployed.